All right, finally, our last question in the practice test is number 36. Sketch the graph of the rational function. F of x equals 5x in the numerator divided by x minus 3 and x plus 2 in the denominator. So let's begin by sketching any asymptotes, dotted lines that'll help guide our graph. Our horizontal asymptotes. For the horizontal asymptotes, we look at the degree of the numerator. Now the degree of the numerator here, if we write it out, 5x, and if we expand the denominator, simplify like terms, you'll see that the degree of the numerator is 1 and the degree of the denominator is 2. So that means that we have a bottom-heavy function, and the equation for all bottom-heavy functions for horizontal asymptote is going to be y equals 0. So that means as you approach positive and negative infinity, this graph is going to flatten out towards 0 or flatten out towards the x-axis, which is y equals 0. For the vertical asymptotes, we're going to set the denominator equal to 0. Now the denominator in factored form is nice because we set each factor equal to 0. So we have x minus 3 equal to 0 and x plus 2 equals 0. X equals 3 is one vertical asymptote and x equals negative 2 is the other vertical asymptote. For oblique asymptotes only happen when the degree of the numerator is 1 more than the degree of the denominator. So this is not going to have any oblique asymptotes. So you can begin your graph by doing a dotted horizontal line through y equals 0. That's going to give us the long-term end behavior. Vertical asymptote at positive 3. And a vertical asymptote at negative 2. All right, so we've got to plot a few other points to figure out what's going on with this rational function. So let's make a table of values. I like to choose some numbers in each, a couple numbers in each interval of the number line that's separated by those vertical asymptotes. So let's do perhaps x equals negative 4, x equals negative 3, and x equals negative 2. Well, at negative 2, that's where you have your vertical asymptote. So if you try plugging that in, you're going to divide by 0. It's an error. So our function can be evaluated, though, at negative 4 and negative 3. Plugging in negative 4 for x into the original function, you get approximately negative 1.4. And you plug in negative 3 into the original function for x, you get approximately negative 2.5. So if we plot those 2 points at negative 4, negative 1.4, which is just eyeballing in here, just a rough sketch, at negative 3, negative 2.5. So those are just 2 points. Because you've practiced these a lot, you can start to notice the trends that are happening with the graphs, that this graph will approach 0 as it goes to negative infinity, and as it approaches negative 2, it's going to go to negative infinity. So that's that side of that piece of the graph. Now let's look at what's happening between negative 2 and positive 3. So let's choose a few points between those, like negative 1, 0, 1, and 2. If you plug in negative 1 into the original function, you get 1.25. Plug in 0, you get 0. Plug in 1, you get approximately negative 0.83. And you plug in 2, you get approximately negative 2.5. But if you were to plug in 3, you would get an error. So let's look at the between those two vertical asymptotes of negative 3 and negative 2 and positive 3. We can plot those points. At negative 1, it's about 1.25. At 0, it goes right through the origin. At 1, it's a little negative 0.8. And at 2, it's a negative 2.5. So we only have 4 points there, but that hopefully is enough to get a good idea of what the graph looks like. If it's not enough, you can always plot a few more points. So it's going to go approach that vertical asymptote, and it's going to approach that vertical asymptote. Now let's pick a few points after to the right of 3, for example, 4 and 5. When you plug 4 into the original function for x, you get 3.3. When you plug in 5, you get 1.8. So let's plot those. When x is 4, we have 3.3. When x is 5, we have about 1.8. Again, this is a really rough sketch, but it's going to approach that asymptote, that vertical asymptote, and it's also going to approach that horizontal asymptote to the right. So out of all of those graphs, the one that looks most like that is C. Take your time when you're graphing these. Take your time to practice all of these questions. If you have any that you're kind of struggling with, it's a good time to email your professor to get help from our Student Learning Center. And for your tests, you may use a single 3 by 5 inch note card with handwritten formulas and examples, and make sure you have that when you are going to be taking your tests. Good luck, everybody.